Hello everyone. Today we will continue this module 5 that is on flood studies. So here we will start lecture 14. In the last lecture, lecture 13, we have learned about the basics of flood and we have seen different types of flood, what are the different parameters which plays critical role in flood, and we have also learned that flood can have both positive and negative impacts. Right. So today we will start this lecture with the flood control measures. Right. So here you can see when we talk about the flood control measures, it has two different types. So the first one can be your structural measures and the second is non-structural measures. Right. When we talk about the structural measures, so it involves the physical construction to reduce the flood impacts. Right. So here the construction work is involved to control the impact or to control the flood situation. Right. So the first one, it can be storage or detention reservoir, it can be levee, the flood embankments, floodways that we modify the floodways, then channel improvement to improve the channel so that this will have better navigation. Right. When we talk about channel improvement, we try to improve the channel, the fluvial system, so that it can accommodate the extra water which is coming during a flood event, right? Then comes the watershed management. So these are different types of structural measures. So this is the example of embankment you can see, so that you will be able to perceive what exactly I am telling you. So these two are different types of embankments. Here you can see this is example of dam and barrage, right. Then comes the levee and flood walls, right. So levee are elongated elevated ridges that develops at the channel floodplain border when overbank flow occurs. So here you can see this is what I am saying, this is the levee, right. So this is the elevated ridges that develops at the channel floodplain. This is because of the sediment which is carried during the flood that gets deposited and slowly they take the form of this ridges, right, and these are known as levees. This is flood wall, you can see here, these are the flood walls which were created to restrict the water during a flood event, right. Then comes the natural detention basin. So you might have seen this kind of pond in your surrounding or this kind of a structure. So these are the natural detention basin. So during a flood, what happens? These work as storage of those flood water. So the spilling will be less, right? When we talk about the flood water harvesting, so here we can have two different category. One where we are using the storage structure to store this flood water. So it can be check dams, it can be nala bunds or percolation tanks. In some other cases, the water spread over the command area, right. So that is also to recharge the groundwater. Then comes the channel modification. In the channel modification, we have deepening of the channel, diversion of the channels, straightening of the channel, because when you are having meandering and you have more water, the flood situation will be more severe, right. So we tried straightening our channel, then dredging and then widening of the river channels. So here you can see this is one example of dredging, and this is the example of flood diversion, right. So you can see how it is getting diverted. Then comes the non-structural measures for flood control. So here we talk about the knowledge that are used in flood, right. So when we talk about the non-structural measures, it involves the use of knowledge practices to reduce the hazard and various awareness program, right. So here we will see some of the example like flood plain zoning, then flood forecast warning, then evacuation and relocation, and then flood insurance. These are different types of non-structural measures which try to reduce the severity of flood, right. So, these are the measures. We will see one by one. So, here this is the first one, floodplain zoning. Floodplain management helps to identify flood prone areas and regulates land use to reduce and restrict flood damage, right. Usually affected by the floods of various return period. So, here you can see 100 years, 25 years or very frequent, right. Different measures can be taken based on the zone to reduce damage. So, here when we talk about the 100 years return period, then how we are utilizing that particular area? So, we can utilize that area to build residential areas or factories or offices, right. If the return period is 25 years, then we can go for parks. If it is very frequent, we do not utilize that particular area. So, here we can see the encroachment and illegal constructions are more because these are not officially allowed. So, here you can see this is the floodplain zoning. This is the example of floodplain zoning. So, here you can see this is the zone where you have warning, then restrictive, then prohibited, then warning again, and this is the cross section of a river channel, right, and this is the water level. When we see the flood forecast warning, so here it can be short range forecast, medium range forecast or long range forecast. When we talk about short range forecast, the river stages at the successive stations on a river are correlated with the different hydrological parameter like rainfall, antecedent precipitation, that is the condition of precipitation in last 5 days, as well as the stage variation at the upstream base location. Stage variation means in the cross section how it is changing, right. So, during the flood period, thus advance warning of 12 to 40 hours are given using this method. So, this is called short range forecast. Here we talk about 12 to 40 hours, right. Medium range forecast, the relationship of rainfall with runoff is studied and flood levels are predicted within a warning of 2 to 5 days. Here you can see it has increased from 12 to 40 to 2 to 5 days. Long range forecast, in this case the information regarding the critical storm producing weather system, the potential of rain as well as the time of occurrence are predicted using radar and meteorological satellite data. So, this will be before this 5 days. Central Water Commission, the CWC in India, they are actively engaged in flood monitoring and forecasting services. CWC monitors flood situation in the country by observing the water level and discharge along the major rivers in the country. They have very good networks so that they can collect the in situ measurement. CWC network is spread on 10 major river system of the Ganga and its tributaries, the Indus or Jhelum, the Brahmaputra and its tributaries, the Barak and the eastern rivers, and the Mahanadi, Godavari, Krishna and west flowing rivers covering 72 rivers and sub-basin over 17 states. So, you can see how actively they are engaged in the flood monitoring and forecasting services. The flood forecasting and advance warning for 148 low-lying areas and 28 reservoirs help in deciding mitigation measures like evacuation of people and shifting their movable property. The inflow forecast of 28 reservoirs are used by the dam authorities for opening the reservoir gate to control the flood water, ensure adequate storage in the reservoir for meeting irrigation and hydropower generation. So that is also done by the dam authorities by using this CWC forecasting. Such services are normally available during the monsoon period, because in monsoon we have more vulnerability to flood. The overall accuracy of the forecast issued by CWC over the past few years is 97%. So you can see how actively and how precisely they are predicting and they are forecasting the flood events. In the CWC website, you can see these contents are freely available. So the Central Water Commission has classified floods into 4 categories. So first one is normal flood, then above normal, then severe, then extreme flood. So based on the water level, they decide whether it is normal or above normal or severe or extreme, right. So here you can see the warning line and the color they are using, right, it is different. So normal flood, at a flood forecasting location, a normal flood occur when the river stays below the alert level. So if you see the cross section, if this is the level, right. So if the water stays below this, it is normal flood. Above normal flood indicated by yellow, this occurs when the river reaches or surpasses the warning level while being below the danger level. Then severe flood, it is orange, is sent out every 3 hours to indicate a severe flood, which is defined as when the water level surpasses the danger level but stays below the maximum flood level. And this is the extreme flood. So this is the highest flood level which is recorded in that particular area. When we talk about the hydrological model, because we are talking about predicting a flood, forecasting the alerts, right. So in such situation, what are the expectation, what are the minimum things that you should know, that I have listed here. So you can see the hydrological cycle, that is very important. The knowledge about the precipitation, knowledge about the runoff, that is required. So when we talk about this hydrological cycle, we include evaporation, transportation, precipitation, infiltration, interflow, groundwater storage, runoff, all these are explained here. Precipitation, which is one of the very important factor when we talk about the flood modeling. So it is the basic driving factor requires in the hydrological model. Thus, it is important to represent rainfall accurately. So we should have very accurate measurement about the precipitation, because your model will have this as an important input. Small river channels are extremely sensitive to precipitation, right. Then comes the runoff, how the area is responding to a particular rainfall or how it is responding to a particular inflow, right. It consists of 3 components like overflow flow, rain that falls directly on the surface water bodies, and interflow, right. Thus from the storm events onset, the amount of rainfall in the surface water in a short period is computed, right. Then we have unit hydrograph. We have learned this in the previous lecture, what is a hydrograph and how it is used to define the characteristic of a particular precipitation or a particular catchment area, how it is behaving with respect to a precipitation, right. So the hydrograph in discharge unit is calculated after the basin runoff is computed. So this stream flow discharge will be measured in the river. Then we go for the routing. It is a technique that helps to predict how the flood wave changes while moving through the river channel or a reservoir, that is the hydrograph shape changes is observed. So here basically what happens in the flood routing, we try to see how the river is behaving and how the hydrograph of a upper stream is changing when it is going to the low lying area, right. So that is being studied here. Then comes the evacuation and relocation. So, evacuation and relocation is very important because we need to help the people who are suffering from this flood in a area, right. So, if we shift them permanently, then it becomes the structural measure, but if it is temporary, it will be non-structural measure. Then comes the flood proofing. So, in flood proofing, we try to raise the building or the walls so that the flood water will not enter into the other areas, right. Then comes the flood insurance. It is very important for some of the areas. The flood insurance is a specialized policy that helps to provide financial stability and protection against the losses caused by flooding. It is like any other insurance, right. It reduces the impact of the loss burden because people who have suffered from a flood, they have lost their property or the assets, right. So, in such condition what happens, this flood insurance will help them to recover fast. So, when we talk about this early warning system, so here it has 4 major criterias. The first one is the risk knowledge, then we have monitoring and warning, then we have dissemination and communication of the alert, and then response from the governance. Here when we talk about the risk knowledge, hazard, risk and vulnerability are studied. In monitoring and warning, we have precipitation, river level, then analysis and triggering factors that are studied here. Then dissemination of the information, that is through mobiles or through television, through news channel, through newspaper. We try to inform the people who are supposed to be suffering from this. Then comes the response. So, the evacuation, search and rescue, relief and goods supply, that is also part of this response. So, this complete chain is known as early warning system. If any one of them fails, then this will not qualify the definition of early warning system, right. So, in India we have major flood affected states. So, here starting from Bihar, then we have West Bengal, then Uttar Pradesh, Odisha, Andhra Pradesh and then Assam. These are major states that are flood affected, right. So, when we talk about this Brahmaputra basin and we see the flood is the major problem, and here we also have seen sometimes the flash flood condition. Then bank erosion is the major problem in Brahmaputra basin. When we talk about Ganga basin, here we have flood, then bank erosion, and then water logging or the drainage congestion is also there, which was not there in the Brahmaputra basin. Then comes the Mahanadi basin. So, here you have flood, then water logging, drainage congestion is there, but here the bank erosion is missing, right. One important aspect is the flood susceptibility mapping. What are the areas which are susceptible to flood, which are having high probability of flood occurrence. So, there are different models which can be used to model the flood for a given area. So, the flood susceptibility mapping helps to identify the areas prone to flooding based on some conditioning factor, right. So, here such map plays crucial role in flood mitigation, because once we know that this area is in the high probability zone and this is very high, that means this particular area need the special attention. The flood conditioning factors which are used in this flood modeling, that are elevation, aspect, distance from the river, drainage density, land use land cover, precipitation, geomorphology, and then NDWI and topographic wetness index. These are used for the flood susceptibility mapping. We will discuss this in detail in the next part of this lecture. For this part and the previous lecture, these are the suggested readings So if you are interested in working in this area, you can refer to these papers, and these are the references which I have used for the lecture 13 and this part of lecture 14. So if you are interested, you can refer to these. Thank you, and we will continue this lecture 14 second part. Thank you.